This is the setup I used for the in-class assignment. I have my Raspberry Pi resting on top of a large cardboard box inside of a cardboard case that I created. The case keeps the Pi from moving too far with the cable plugged in, but also having a place to mount the camera. The camera is mounted through this little hole in the front that I cut out and taped onto the cardboard with electrical tape. It then has a view that is a pretty straight shot of the area in front of my door and the pathway leading up to it. This is my code for the smart doorbell assignment. My code is pretty much only the code that was implemented in lecture. In fact, even the thresholds that were somewhat arbitrarily chosen seemed to work really well for the angle that I had. But I was only able to test for about 5 hours on Friday, so there's a good chance that if it was windy or rainy or something, that these threshold values wouldn't have worked quite as well. Starting off, I imported everything into Python, and then I defined my mask through the points that I determined through select ROI. My mask has about 9 points to capture both in front of my door and a bit of the walkway leading up to the door. It then runs through and grayscale blurs and shrinks the image. In the while true loop, I tell the operating system to take two 640 by 480p images, with 1 second of downtime between the two images. I suspect that lowering the downtime would improve some of the results I had, but like I said, I didn't test too much. Next, it runs through the masking function and initiates the zero array to later be populated. Next is the pixel differences between the two images. If there is a great enough change, then the pixel is set to a high value of 255. Then, if the image has enough high pixel values, the program tells the user that the smart doorbell has detected someone and begins to take a 10-second video of them. Once done, it converts that video into an MP4 and saves the masked and grayed images. It then uploads the video file to Dropbox through the Dropbox uploader app that we have. It then sends an email from a dummy email that I created to my TerpMail account containing those images that it just saved, the grays, the masked, and also the two original images that it took. It then sends a text message to us saying that the email has been delivered. And it also sends a text message to my phone through the Twilio account that we have. Then, if nothing is detected, it simply prints that nothing is detected, and then it will print the number of loops that it's gone through since it started. This is a demonstration of the code working in real time. So I did this at night, so I kind of had to trick the sensor with a flashlight on my camera because it doesn't work very well in low light situations such as the night, but it does prove that it does work at a given time. You can see on the top right, it's like 10 o'clock, 9 o'clock when I took that image. But I also ran it 2 more times, once during the middle of the day and once in the evening to see the difference in quality and if it could still detect me, and it detected me perfectly fine in both scenarios here. And then these are the images from the midday, the ones that were used for detection, the masking and the blurred images. Got these from the email. And these were the images for the evening. Again, the initial detection, the masking and the blurring. And then this is me showing that it worked, and it did send it to Dropbox, and that's where I got those video files from. And then this is it showing that it worked in my email, because again, this is where I got those images from. And then in addition to all of that, I also do have another image that proves that it was text messaged to me from Twilio, just kind of showing all the functionality.